Unit 2, Learning Target Number 2. Use inverse operations to solve one-step addition problems. Here we have some scales that are balanced. On this side of the scale we have 25-pound weights, and there are 4 of them, so that gives us 100 pounds. On this side we have another 4 25-pound weights, which also gives us 100 pounds. So the scale is even because the two are equal. An equation. In this case, we have still our 4 25-pound weights on the left side, but we have subtracted 25 pounds from the left side. And what happens is that the scale is now no longer balanced. We've taken away 25 pounds from the right side, so the left-hand side sinks. So the question is, how can we balance the scales again? Well, we could remove 25 more pounds from this side, and then all of a sudden our scales would be balanced. This is the basis of what we're going to do with equations. When solving equations, we're going to follow 3 rules that will get us through every time. If we follow these 3 rules very specifically, we can get the solution every time. The first rule is to get x all by itself. Our whole job when we are solving equations is to get x isolated and all by himself. We want to make him lonely. We want to get x all by himself. Now, to do that, we are going to use what are called inverse operations. Inverse just means opposite. So the opposite of multiplication would be what? Division. Exactly, and the opposite of division would be multiplication. So these two are inverse operations. X, multiplication, is the opposite of division. Addition's inverse is subtraction. So the inverse of addition is subtraction, and the inverse of subtraction is addition. We're going to use these operators to get x all by himself. And then lastly, we're going to remember that whatever we do to one side of the equation, if we do it to this side of the equation, then we have to do it to the other side. Whatever we do to this side, we have to do to that side. So let's get started and look at an example here. Number 1, we've got x plus 7 is equal to 12. And remember that our goal, again, is just to get x all by himself. Well, how can we do that? Right now, x is not by himself. He has 7 added to him. One thing that we could do is we could subtract 7. If we subtract 7, then x will be all by himself. We subtract 7 from this left side, and we get 0. Remember, this is the inverse operation. We were adding, and so to get rid of this 7, to get x all by himself, we subtract that 7, and that gives us 0. You can cross right through those guys. Now, that is how we get x all by himself. But if we do that, we have a problem. Before, x plus 7 was equal to 12. But x all by itself is not equal to 12 because we have removed 7 from this side. That means that this side is no longer balanced with this one. So how can we fix that? And that is where rule number 3 comes in. Whatever you do to one side, you must do to the other side too. So we take that same equation and we say x is equal to 12. And now we're going to subtract 7 from the other side. We subtracted 7 from the left side. We're going to subtract 7 from the right side, and that is going to give us x equal to 5. And now the equation is balanced again. Let's take what we learned and put it into practice. Here we have an equation. X plus 15 is equal to 23. We don't know the value of x, so that's what we have to find. And we're going to do that by following our 3 steps. Step number 1, get x all by itself. So we need to find a way to get x all by itself. Well, right now we're adding 15 to x, so if we want to get rid of it, we'll use the inverse operation. Rule number 2, use inverse operations to get x all by itself. So the inverse of addition is subtraction. So we will subtract 15 from this side of the equation. That's going to give us x plus 0, which is x. Now on this side, we have to follow rule number 3. First off, we got x all by itself by using inverse operations. So number 3, whatever we do to the left side, we have to do to the right side. Since we subtracted 15 over here, we're going to subtract 15 over here. Let's do our subtraction. You can't get 5 from 3, so you have to borrow 1 from the 2. That gives us 13 over here. 13 minus 5 is 8, and 1 minus 1 is 0, so x is equal to 8. Let's say we want to check our answer and make sure that it's correct. we'll come over here and we'll check our answer. To do that, we start with our original equation, x plus 15 is equal to 23. We got that from right over here. We start with our original equation, and then we take the value that we got for x and we plug it in for x. And what we wind up with is 8 plus 15 is equal to 23. And is that true? Well, 15 plus 8 is equal to 23. And now both sides are the same. If they're both equal, then our answer is correct, and we can give ourselves a check. This problem is the same kind of problem, it's just arranged differently. Notice the x came first in this one. In this one, it comes second. That might throw you confused just a little bit. But understand that when we have a 6 here, we really have a positive 6. We still want to get x all by itself. Still want to have x isolated and all by himself. To do that, since we have a plus 6 here, we're going to subtract 6. If we have 6 on this side, we need to subtract it and get rid of it. That leaves us with 0 plus x, or really just x. And then we follow rule number 3. We used our inverse operation, which was subtraction, and we got x all by itself. Rule number 3 says whatever we do to the left side, subtracting 6, we also have to do to the right side. So we subtract 6 over here. 19 minus 6 is equal to 13. So let's check our answer. Start with our original equation. 6 plus x is equal to 19. And plug in 13 for x. And we get 6 plus 13 is equal to 19. And is that true? Well, this is 19, and that's 19. We're correct. Now let's take what we've learned and use it to solve a problem. Sam and Jenna are making homemade peanut butter cupcakes. Jenna made 21 cupcakes. Together, they make 33 cupcakes. We want to know how many cupcakes did Sam make. Now we know that Jenna made some cupcakes. Jenna made 21. And we know that Sam made some cupcakes, but we don't know how many, so we're going to put a question mark in there. But we do know that when you add these two together, that you get 33 cupcakes. So they made a lot of cupcakes together. How can we write that as an equation? Well, Jenna made 21, and Sam made I don't know how many. So we'll start with Sam, we'll say s for his variable, and then we'll say s plus 21, and that's going to be equal to 33. Sam's number of cupcakes plus Jenna's number of cupcakes is equal to 33. Then we simply solve our problem like we did the other ones. Solve our equations like we did the others. We're going to subtract 21 to get s all by itself. We're going to get s all by himself, so we subtract 21. Now, whatever we do to the left side, we have to do to the right side. So we'll subtract 21 over here. That's going to leave us with 12. And s is equal to 12. So we wrote our equation, which was s plus 21 equals 33, and we solved it to get s equal to 12. Let's check our answer just to be sure. 21 plus s, or s plus 21, is equal to 33. We replace s with 12. 12 plus 21 is equal to 33. Does that give us the right answer? Well, 20 plus 10 is 30, plus 3 gives us 33. And we know that our answer is correct.